Hi, I'm Sena Dikmeci. I am a computer engineering student. Today I'm going to make a presentation about predicting temperature in London. Let's start. What is the subject and purpose of my project? The aim of my project is to develop a machine learning model to predict the average temperature in London. My goal in building this model is to ensure that the root mean squared error is 3 or less. In addition, I need to log and monitor my experiments and model performance using mlflow. Now we are going to see steps about my code. Step 1, importing the required models. This block imports libraries needed for pandas and numpy for data manipulation, mlflow and mlflow.sklearn for experiment tracking and model logging, matplotlib.pyplot and seaborn for data visualization, sklearn models for data preprocessing, splitting, model training, and evaluation. Here we see step 2, reading the data. Loads the CSV file London weather CSV into a pandas data frame named weather. This file presumably contains weather data for London. We see step 2, exploring and cleaning the data. Displays a summary of the data frame showing column names, data types, non-null counts for each column. This helps to identify any columns with missing data and the types of data present in each column. Step 4, converting and extracting data information. Conversion converts the date column to a data time format using the specified format. Extraction extracts the year and month from the data column into new columns, year and months respectively. This allows for easier aggregation and analysis based on these time components. Step 5, aggregating and calculated average metrics. Aggregation groups the data by year and month. Average calculation computes the mean of specified weather metrics for each month and year, creating a new data frame, weather per month. Step 6, visualizing data relationships. We use Seaborn to create a line plot of mean temperature over the years to identify trends. We also create a heat map of the correlation metrics to visualize relationships between different variables in data frame. Step 7, selecting features and defining the target. In this step, we select specific columns from the data frame to be used as features for our machine learning models. These columns are listed in feature selection and include mass, cloud cover, sunshine, precipitation, pressure, and global radiation. We also define the target variable target_var, which is mean temps. Finally, we remove any rows from the data frame that have missing values in mean temps column, ensuring that our target variable has no missing values. Step 8, subsetting feature and target cells. We create the feature matrix X by selecting the column specified in feature selection from the weather data frame. We also create the target vector I using the column specified by target_var. These subsets will be used to train and evaluate our machine learning models. Step 9, splitting the data. We split the data into training and testing sets using the train test split function. The test size parameter specifies that %33 of the data should be used as the test set, while remaining the %67 will be used as the training set. The random state parameter ensures that the split is reproducible, meaning that running this code again will be produce the same splits. Step 10, inputting missing values. We handle missing values in the feature matrix X using the SimpleImputer class with strategy set to mean. This means that any missing values will be replaced with the mean value of the respective column. We first fit the inputter on the training data using imputer fit transform, which computes the mean of each column and replaces the missing values accordingly. We then transform the test data using imputer transform, applying the same imputation strategy based on the means computed from the training data. Step 11, scaling the data. To ensure that our features are on a similar scale, we use the StandardScaler class to standardize the feature matrices. This process scales the features to have a mean of 0 and a standard deviation of 1. We first fit the scalar on the training data using scalar fit transform, which computes the mean and standard deviation for each feature and applies the scaling transformation. We then transform the test data using scalar transform, applying the same scaling parameters computed from the training data. Here we see our step 12. Now we will see the explanation. Step 12, training, evaluation, and logging models. For each step, Tin starts a new mlflow run, trains LinearRegression, DecisionTree, and random forest models, logs each model with mlflow, predicts the target variable on the test sets, and calculates RMZ for each model, logs the maximum depth parameter and RMZ metrics. Step 13, retrieving experiment results. Finally, we retrieve and display all the logged runs and their metrics, parameters, and artifacts from mlflow using the mlflow search runs function. This allows us to compare the performance of different models and configurations based on the log results. Here you can see my full code. And here is my output of, and here's the output of my code. Thanks for listening.